Hi, welcome to Flower Academy. This course is about converting between programming bases. So first, we'll introduce some programming bases. And literally, a programming base means a representation of a number. And we know numbers, right? But there are a lot of representations other than decimal system, the one we are now using, that could represent numbers. So for instance, we have binary system, meaning to take 2 as the base, octal system, meaning to take 8 as the base, decimal system 10, hexadecimal system 16. What we are familiar with is a 10-base system, aka decimal system. We have 9, 10, 11, and so forth. But regardless of what type of representation you take, the value of a number is independent of that base. For example, 10 could be displayed as 10 in a 10-base system, or 1010 in a 2-base system, or A in a 16-base system. So now we're going to introduce you some characteristics of individual programming base. For binary system, it is only composed of 0 and 1, corresponding to the presence of electricity. By convention, we write them in 8 digits, meaning for 1 byte, but we could also write them in 4 digits, half a byte. And each digit, we say every digit, is referred in computer science as 1 bit. And binary system simply means that you take 2 as a base, so there couldn't be any presence of the character 2. And also, every time the one number exceeds the value of 2, or equals the value of 2, then this number should increase its digit. For example, we have 1, right? But if we have 2, then the additional 1 could be added to the second digit to 1, and the first digit becomes 0, so the digit increases. And the other another one is decimal system. We are all using this. We are all taking 10 as the base. So every time a number it exceeds 10, then the digit of it increases. And the third one is octal system, so there couldn't be any presence of 8. The fourth one is hexadecimal system. And in this case, since you need to represent 1 from 0 to 15 as 1 digit, so you need to use English alphabets to represent numbers that are higher or equal to 10. So this is a trick we use, right? And now we know the forms of some simple representations of numbers. How do we interpret these forms? Once I see 3a, what does it mean? What number does it refer to? Well, a base also stands for what value does every individual digit have. For instance, for a binary system, 1111, and the nth digit represents a value of 2 to the power of n minus 1. So the first digit, starting from the right, has a value of 1 times 2 to the power of 0. The second one has 1 times 2 to the power of 1. The third has 1 times 2 to the power of 2. And the last has 1 times 2 to the power of 3. So the value as a whole could be calculated through 1 plus 2 plus 4 plus 8, meaning 15 in decimal system, or F in hexadecimal system. And once we are interpreting the value of one number, what we are really doing is converting between that base to a base we are familiar with. But sometimes we are not really only converting it to decimal system. So now I'm gonna introduce you other 2 ways of converting. So in this one, it is a general formula for you to convert, especially it works for you to convert higher bases to lower ones. And what you're gonna do is first divide the number by the lower base. for example 2, and then you need to get the integer quotient for the next iteration. So you got the integer quotient, and also you leave the remainder. I mean, if it has a remainder. And the remainder in this case must be 0 or 1, right? Because if it is 2, then it won't be a remainder because we're dividing it by 2. I mean we're dividing the number by 2. And then, you repeat the steps until the quotient finally equals to 0. And when the quotient equals 0, you reverse all the orders of the remainders you get. And then you could form like a system you want. And now I will introduce another method, and in the following examples we'll carefully examine how do we really use those methods, and then you could get more clear out of it. So the next one is that, for example, what if you want to convert a binary system to octal system or to hexadecimal system? You know that 8 is the power of 2, right? 2 to the power of 3 is 8, and 2 to the power of 4 is 16. So there are some tricks for you to directly convert binary system to octal or hexadecimal systems, vice versa. You first write down the binary system with 3 or 4 of them in a packet. Like you could, in the example, you could write the binary system in the forms of dividing them into different little groups. And it could be 3, it could be 4, depending on whether you are converting it to octal system or hexadecimal system. Then you convert every pocket in a number to octal or hex. For example, you could convert 010 to 2, 101 to 5, 10 to 2, right? 252 if you are converting an octal system. And then you link them together, very simple, 252. And you end with 252 as your answer for converting it to octal system. It is quick, right? You just divide into little groups and convert every one of them directly, and finally you link them together. Then is conversion between bases. So we're all talking about conversion between bases, so now there are 3 examples I could provide with you with the 3 methods. The first one, we could convert between 1010, this this binary system, to decimal system. So in this case, 0 represents the value of 2 to the power of 0. 1 represents the value of 2 to the power of 1. Then 0, 2 to the power of 2, 1, 2 to the power of 3. And we add them together, we could get an answer of 10. And if we want to convert this to hexadecimal, because we know that 10 in English alphabet is A, right? 11 is B, 12 is C, and 15 is F. So we could directly say A. Of course, there's an alternative for you to do that. You see, 1010, you want to convert this to hexadecimal. So this is basically the main method. But if the number is much bigger than 1010, like 1010, 1010, then how do you convert this? You don't need to count it for so much, for 2 to the power of 7, 2 to the power of 6. If you want to do 1010, 1010 to hexadecimal, you could simply write AA, because you could divide them into 2 groups, into 1010 and 1010, and you could convert them individually. So A, and you link them together. AA is the answer. So it will be much more quicker. The other example is when you convert decimal number into binary system. For example, 10. You want to convert 10 to a binary number. You first divide 10 with 2, and you get an integer quotient 5 with a remainder of 0. Then you make 5 divided by 2, you get an integer quotient of 2 with a remainder of 1. Then you divide 2 by 2, having an integer quotient of 1 with a remainder of 0. At last, you want to divide 1 by 2, having an integer quotient of 0 so it ends the iteration and having a remainder of 1. And you reverse the order, 1 0 1 0, so it becomes 10, right? So 1 0 1 0 becomes the answer of 10. And this is quick as well. For the third method, what if we are converting 3A into binary system or into decimal system? Actually, just as what I've mentioned, in this example, here, I already gave you an example about how to use the third method. But in this example, you could try to do it again. So for it in binary system, you could simply convert it back. I mean, this is an alternative use of the third method, okay? So in this case, you want to convert A first, convert A into 4-digit binary number, in this case 1010, convert 3 in 4-digit binary number, in this case 0011, and you link them together, 0011 1010. So you could see that this is actually a reverse method of using the third method, right? But it works as well because of the magic of the fact that 16 is indeed 2 to the power of 4. So you could have 4 digits of binary, and these 4 digits could represent 1 digit in hex. And you could check this one by converting it to decimal system, which I read it at first. A times 16 to the power of 0 plus 3 times 16 to the power of 1. We have 58. Now there are more exercises for you to try. You could do these 4, and I will leave the answer at our next video, okay? At the very beginning of our next video. So that's it. That's basically like the basic mechanism for you to convert between different bases, and these are also the questions you will see in AP exams. So we will see you at next video, and if you enjoyed this one, please subscribe our channel. See ya!